Hello and welcome back to the Oxford MAT Livestream. My name's James, and joining us today is all of you. Let us know where you're watching from in Slido. You can join the Slido at slido.com/MATLIVE, and that's also more or less how you find the homepage for this MAT Livestream experience, which is on the maths bit of the Oxford website. So maths.ox.ac.uk/r/ and then MATLIVE, Maths Live. That's where you can get resources to support the live stream. It's where you can get answers, solutions, and detailed working out stuff. It's where you can get links to previous episodes of the live stream. But if you're watching this on YouTube, then hopefully you've found this on YouTube and other videos too. Right, good. Are we here? Are we doing the thing? I think we are. We've got chat running. There we go. Anonymous person is having dinner. Someone's got stats about Matt. There's a request that we retile the. Just before we went live, there was a request in chat that we retile outside the front of the building because we've currently got Penrose tiles out there. Maybe we should have periodic tiles. The single sorry, not periodic tiles. That would be rubbish. We've got periodic tiles out the other side because the maths department on one side is beautiful Penrose tiles and on the other side squares. So we've got periodic tiles and we've got aperiodic tiles, but the suggestion is that we have the new aperiodic tile found a year ago with one tile, one stone. The retiling took ages. I put a link to the time-lapse footage of laying the Penrose tiling outside the maths department 10 years ago when the building was opened. Well, before it was opened, I guess. Put the floor in before you open it. Hello to Anisha and Isaac and Sophie in chat as well. Good showing here from people in chat. The year 10 kid is a reminder to me that you don't have to put your name in Slido if you don't want to. You could put some fact about yourself if you like, or you could use somebody else's name. As Nikita Mazepin reminds me, or you can be anonymous. I sometimes like to imagine that all of the anonymous people are the same person, but I think it is a sort of one of those anonymous collectives that I've heard so much about. Right, okay. People in chat are always very well behaved. You're always really nice to each other. That's something I like to see. It's very helpful chat. You're also very helpful to me. If I make mistakes, it's probably because I'm a bit tired. Maybe you can point those out in chat as and when I make them. Somebody saw us at the open day. That's good. You got to see the tiles as well. You come to the open day, you see the tiles. It's a classic mathematician experience, right? To visit a building and just looking at people's shoes, maybe looking downwards. See, we've put something nice there for you to look at. Well, while we're all looking at each other's shoes, avoiding eye contact. Right, good. I got to the joke in the end. I had the joke in mind, and I got there in the end. Okay, what am I doing? This is not quite right. This needs to be like that, so that it's a bit tidier. That's not quite right because chat's on top of it. We will get there. Okay, I think we're good. I think we've got geometry. That's the plan for today. We've got some revision notes about geometry. We've got some what I'm calling revision questions about geometry. We'll find out whether those are revision for you personally or not. We've got some people who are here because they're about to take some sort of maths test for university admissions, maybe maths admissions test, my one, for Oxford, or maybe you're doing a different test for other universities. But I'm also aware we've got some people who are a bit younger who are maybe using this as a sneaky way to learn A-level maths. And hopefully you've got some other way of learning A-level maths or equivalent as well. And this is not the only thing that you've got for learning A-level maths. Please don't tell me that I'm your A-level maths teacher. This is the only way you're going to learn it. But if you're here to see some content in advance, then we're going to go through it very quickly. And maybe you're the sort of person who likes to see all of the content very quickly. Right, okay. I think that's an advert for what we're doing. Let's check how people's day's been. I like checking how people's day's been. There's a kind of vote in chat for how's your day been. While they're voting in chat, we will have a look at the syllabus for what we're doing today. The maths syllabus, I should say, is the list of topics used for the maths admissions test. It's pretty much exactly AS level mathematics, which might be equivalent to something you're learning. There are going to be a couple of topics from the full A-level maths, just a little bit in a couple of weeks' time. But this is what we've got today. Equations of straight lines and circles, which I think people learn near the start of A-level. Basic properties of circles. I've got a list of some basic properties of circles, don't worry. Lengths of arcs of circles, something to do with the perimeter of a circle. I think some people learn about how big is a circle at different ages, at different times in your education. We're going to make sure everyone's on the same page today. But the big thing is coordinate geometry and vectors in the plane. The plane here means two-dimensional space. So we're going to think a bit about explaining where stuff is in 2 dimensions. I need 2 numbers for that to explain what those are, and that's what we're gonna do. Someone in chat whose username is an entire school, so I wonder if they're watching with a kind of watching party at an entire school. Hello, if that's you. They ask if we're going to include TMUA questions, to which the answer is no. There are plenty of MAT questions, and MAT questions are good practice for the MAT. That was true this year, like it was last year and the year before. So I'm using MAT questions. If you would like some TMUA questions, you can get those from the Cambridge website, I think. There you go. Yeah, and good question in chat that reminds me that I'm supposed to tell you about a sample test. There is a sample test. Don't get too excited. There is a sample test for the MAT to show you what it might look like in the Pearson Test Centre, when you go to a Pearson Test Centre to take the MAT this year, 2024, in a Pearson Test Centre. Don't get too excited. You've seen things on screens before. You're seeing this on the screen, and the test is a lot less exciting than this. He says, look, a triangle and a square and a circle all at once. Anyway, never mind. There is a sample test. I will put a link to it on the MAT page quite soon. The reason I'm hesitating is because it uses past questions. So the solutions are out there. Some of the solutions are on this stream. But we haven't yet uploaded a neat document with all of the solutions for the ones we've used in the practice test. So as soon as I give you the link, people are going to ask me for the solutions. And at the moment, they're kind of scattered across from wherever I got these past questions from. So I'm slightly delaying until I've got my solutions together. That's not a great reason, is it? I should just get on with it. Right, okay, we're going to teach geometry. We're going to do some MAT questions. After the stream, probably tomorrow, I'm going to put a link to the sample test onto the MAT page, which you can find from the MAT Livestream page. I'll put it there as well. Okay. I'm saying this to a recorded video so that I can be on the record that I'm going to go and do a thing. Good, right. Don't make it easy for myself, do I? New MAT format, very briefly. 25 multiple choice questions, 2 longer questions. For the multiple choice questions, please select the right answer. For the longer questions, you'll be instructed to explain your answer. There will be text boxes where you can type in your explanation. You're not expected to type anything weird. It's just typing in English, words explaining things. You've got a standard keyboard, so numbers and basic symbols if you want to. That's the long questions, but like a normal MAT paper from last year, or the last normal from the last 10-15 years, you've got some multiple choice questions and you've got some longer questions where you'll explain your working out. There will be a search tool. Sophie would like a search tool. Let's put chat back on since I'm talking to chat. Oh, no, there's a poll. Oh, having quite a good day. I guess people are happy about the football. Oh, maybe not. Depends if we've got viewers from around the world and everywhere. Shouldn't assume that everyone is excited by the same sorts of football as me. Sophie's got a good question to find Pearson centres. There will be a search tool when registration opens. They already physically exist. You could try and find them, but we're going to make that much easier for you when registration starts in August. So don't worry, we know that people want to find them. Good. Hi to Aya and Maya who have joined as well. Maths, what's your unrelated? There's an unrelated question which I missed. I'm now scrolling down to find the unrelated question, which is probably an error. What have they said? Are there any books I recommend in preparing for MAT? Yes, this. Let's go. This is sort of a book, right? I know it's not like an actual book, but look, it's got words in it, and it's got revision notes. And if you print all of it, it's roughly book-shaped, book-sized, I think. It's free. It's a PDF on the website. That's what I've done. I've written not quite a book. Let's go with the not quite a book. What a sell! What a sell! I've written not quite a book. Put that on the front of the book. Not quite a book, dash. James. You're probably aware that you can describe where stuff is. This is the revision section now. You're probably aware you can describe where stuff is in the plane with two numbers. I've got this lovely grid on my whiteboards here, so I can describe where stuff is by describing how far to go along this way and how far to go along this way to get to some treasure or something. Like if I were giving a pirate directions to get from where they've started to the treasure, I might say something like walk 5 squares east and then 1, 2, 3, hang on, counting, 4 squares east and then 3 squares north. And if I have to do this quite a lot, I might come up with some sort of shorter notation to explain that this means 4 squares east and then 3 blocks north. So maybe I'll write it like this: 4 squares east and 4 squares north, whatever that means. I said blocks there. I think I was imagining something like New York for a moment. Oh yes, good suggestion. There was a question about average MAT scores are on the MAT website. Yes, chat answered somebody else's question. Thank you. There was a question about average MAT scores and distributions of MAT scores. They're in the feedback PDFs on the MAT website. Forgot to say it. Thank you. Good thing about pirates getting to treasure is that it doesn't really matter what route they use to get to the treasure. The treasure just, that's where it is. There's enough displacement that it doesn't matter how you do it, so long as you end up being displaced like that. So it's not really a story about the journey, it's a story about the outcome. The outcome being treasure, where have you got to? So people do draw these kind of straight line arrows from A to B, where they're imagining that you go, oh, can I do an arrow like this? Is this going to work? Is this going to be good? Yeah, it's not a straight line. Too many features. Yeah, people do draw these kind of straight line arrows to get from A to B, imagining that you're progressing towards the treasure as the crow flies. Maybe you're a magpie or something. They love treasure. You might be going from A to B like that. Good. Okay, so different ways you might store that information. If you've got to direct a lot of pirates to a lot of treasure, then you'll need some sort of shorthand notation to explain what they need to do. But the key thing is that you need 2 numbers. One number won't cut it because they won't know which way to go. Of course, you can think about this other ways of how you might direct a pirate to some treasure, other ways you might give the pirate information. You may be aware of kind of some sort of angle system you could use, some sort of bearings that they might use for boats. Bearings is a way of talking about the angle that you might move at. I suppose that you could start talking about like this angle theta if you want to explain aim yourself in this direction and then walk a certain distance. That gets us towards thinking about, for example, the magnitude of this vector. I think I'm getting ahead of myself. Where am I then? Yeah, okay. The story of least action. Yeah, it's 15th of August, and Sophie, that is on the MAT website for MAT registration. Are we good? Are we up to date? Yes. I'm trying to keep an eye on chat as well. It might not be on the screen, but it is on my physical screen over here. I'm going to try and keep an eye on that as well, although I'm aware we're having about 2 or 3 conversations at once. I can handle that. My attention span can definitely handle this. There's this idea about displacements. I think the first time you meet vectors, they are all describing where stuff is relative to the origin. So you might have this idea that there exists an origin in space right here at the center of the universe, and then all other points you can describe where they are relative to that origin. And that's nice if everybody's agreed where the origin is, but perhaps a more realistic thing is to describe this kind of displacement relative to where the pirate ship is now. I might have this idea that it's the displacement for what they need to do. Okay. Vectors can be added by adding the components together. Now what this means is if I want to make it slightly harder for the pirates and give them a sequence of instructions, so we've already seen this, just to get them to go anywhere, probably give them 2 numbers. But if I want to give them a longer sequence of instructions, then maybe I tell them to go something like 4 squares east, 3 squares north, and then you find an amulet or something and it's all great, and then I want you to go 5 east and 12 north, or something like that. And then the totality of what will happen if you do both of these instructions is something like this vector plus this one for how far you've gone overall. And I suppose sort of obviously if you're thinking about it like this, but not at all obvious if you're thinking about it in abstract mathematics, is that you can just add the components together. 4 plus 5 is 9, 3 plus 12 is 15. You've probably seen this and just sort of accepted it quite quickly, that when you add vectors together, you just add together the components. So the x component and the y component, just add those numbers together separately. I suppose humorously, this is exactly how you learnt not to add fractions when you were a bit younger and you learnt about fractions and you wanted to add some fractions together. You might have tried adding just the top bits and the bottom bits together separately and then been told that's not how you add fractions. And then years later you meet these things called vectors, which look pretty similar. They've got a stack of numbers in there, and you're told that this time you are allowed to just add together. That's why I'm saying it's not obvious that the notion of adding these things together doesn't have to be the operation adding component-wise, but that is what we do if we want the total displacement. I should probably draw a diagram of this, shouldn't I? Like the pirate going over here, and then it's got to navigate all these shapes. 1, 2, 3, 4, 5, and about 12 up. So it's going to think it's going to be direction. It's going to be to avoid the triangle and square and get to the treasure up there off the page. And then the vector 9, 15 describes the kind of total journey to get from starting point to the end point. Okay, good. Instead of writing, hang on, what's this? Instead of writing vectors up and down, can we put it in normal coordinates like in Spain? I don't know about Spain, but do you mean this thing here? Is this Spanish? So chat suggestion that maybe this is how they write vectors in Spain. It's also how I write vectors sometimes. I think I'm interpreting what they've said correctly. I quite like this as well. Quite like these stacks. For the mathematician's test, I don't want people to worry about any differences between these. I think some people in school learn that these are for different contexts or have different meanings. One of them's coordinates and one of them's a displacement vector, but let's not worry about the philosophy of it too much. I'm interested in calculating things with these. Like, where's the treasure? Yes, right, okay, that's an endorsement from two anonymous people in chat have endorsed that as a Spanish way of writing vectors, which is excellent information for me, because now that's something I'm going to say a lot. Good, right. I hope we can all agree about facts about magnitudes and distances between things. And actually, I think before you learn vectors or anything like this, you learn about Pythagoras. So maybe you've seen this idea about squaring two things, adding them, and taking the square roots. There's this kind of link to Pythagoras, right? So in some sense, this is 4 and 3. Then this is square. Oh, down here. I'm down here. Square root of 4 squared plus 3 squared. Oh, and that's actually 5, isn't it? That's nice. Doesn't have to be a whole number, but I've got my favourite triangle, the 3, 4, 5 triangle. It's also an American way. You see, it's an American way, but see, okay. The US has stated some claim to vectors being written sideways. And there's questions about multiplying vectors and matrices, to which the answer is no, not on the mathematician's test because it's not on my syllabus. Let's have a quick look. I suppose the syllabus just says vectors in the plane, doesn't mention matrices. So no questions about matrices. And then somebody else asks, are I and J hat in the syllabus? Now, I think I and J hat, which people sometimes write like this, is a different way of writing vectors like this. But you might have the same information, right? Except you have got this symbol I hat, which means the pirate should go east, and you have the symbol J hat, which means the pirate should go north. I've seen this before. We don't traditionally we don't use this in the questions. When we write MAT questions, we have pretty consistent notation to use either of these two things up here. You're welcome to use this in your working out if you like. I don't know what you do in. Yeah, I have seen this as well. Sometimes people do sometimes people will name their vectors like this, E1 and E2, which is then where it's easier if you have lots of dimensions. You don't run out of letters. I think the claim is that people in Spain write all of their vectors like this. I'm not certain how true this is. Yeah, and there's some chat about Olympiads, and Sophie is correct that not everyone does Olympiads. And how would Oxford know about them anyway? I mean, you might tell us about them in your personal statement, but not everyone would. Okay. Right, what am I doing? What am I doing? It is unrelated to talk about Olympiads, because I think Olympiads don't have any vector stuff in at all, do they? Or is it you could use vectors to do some of the geometry questions, but it's, I think, not a good idea on Olympiad questions to split everything into coordinates. This is maybe not good advice if you're doing the IMO. It's the International Maths Olympiad next week. If you're in that and you're watching this stream for tips, then I don't think I've got any good tips for the International Maths Olympiad next week. I'm sorry. I've got the formula of a straight line. Good luck with the IMO. Right, okay. Some of the chat says, yes, we do. Possibly for Americans writing vectors as a thing, and not for having the IMO next week. Right. Although, who knows? I met the UK team recently, so maybe they've joined in. Right, okay. They should be getting ready for the IMO. Right, what are we doing? We've got the formula for a straight line. I know several different ways to write the formula for a straight line. Not bragging, just showing you some of them. The first one that people seem to learn is this one, where m is called the gradient. You do this thing called rise over run, where you have a sort of line. You think about the rise over the run for like the difference in y values divided by the different x values if it's going through 2 points, and you have this kind of constant on the end. But I also like the way of writing this as sort of mx minus x1 plus y1, which is sort of too many constants. Because really, a line should only have 2 constants in it, really. This one's got 3, which is a bit too many. But this is a good format if you don't mind having an extra constant around. You could simplify this one a bit if you don't mind having an extra constant around. And this is a good format if you know it goes through the point x1, y1 with gradient m, which is sometimes the thing you know. So I find myself writing this out quite a lot if I know that a line goes through a point with a particular gradient, and then simplifying it if I have to, rather than writing down y equals mx plus c and solving for the 2 constants. A quick example, let's say you're looking for the line through -1, 0 with gradient 1/2. So what you could do is set up y equals mx plus c and use the fact that it's got gradient 1/2 and use the fact that it goes through -1, 0 to say, these are equations for m and c, let's go and solve them and then work out what's going on. Or you could write down y equals 1/2 x plus 1 plus the constant is 0. And then maybe you want to multiply out that bracket or simplify something. It's cheeky of me to pick an example where the y1 is 0. I think that is, that's not a fair comparison, is it? Your own mileage may vary. What do people in chat prefer? People in chat calculating c. Oh, either is fine. If the question says find c, and c is defined in the question, then you should try and find c. Try and find this number, right? In here, it's kind of disguised a little bit that c is something like y1 minus mx1. So you might have to do, I might have to do one extra bit of calculation to be like, aha, this is half plus 0, that's 1/2. Okay, might get that number. And somebody else asks, will we get lots of scrap paper to write on? The answer is yes, even though the actual test submission is online and the questions are online, you get this booklet of, it's laminated paper so that it's wipe clean, but it's a lot of space for writing. And there's a system which we're working out the details for, a system where you can get, I hope, arbitrary amounts of it. The wipe clean nature is so that they can reuse it. Good. And we don't collect your rough working, but you have rough working to during the exam work out your answers. Unless you can, I mean, for the long questions you can type a lot of stuff. So you could type your thoughts and feelings in there if you like along the way, but you don't have to. I mean, if you want to backspace things that you've decided are wrong, then that's allowed as well. Good. Hi. Quick shout out, people joining. Sophie always uses y equals mx plus c, but is trying to learn this one as well. Good, okay, we've got hot tips for equations of lines. This is the sort of advice that people come to this live stream for. I'm teasing a little bit. We can hopefully do interesting things with the lines. We can aspire to do more than just find a line. Maybe start intersecting these things together, crossing them with across some circles or something, finding points of intersection, doing all sorts of things, can't we? Because we've got a way here of turning the lines into equations, and you're really good at equations. Some of this is about linking skills together, right? So we have a live stream a few weeks ago about algebra or polynomials or something, and we have one today about geometry, but some of the things you learn in geometry are a way of converting problems into algebra. And sometimes when you're doing an algebra problem, it's a good idea to convert it into geometry and have a look at it. So remember that the links between things are important, and for tests like the math submissions test, sometimes you're combining ideas together into the same question. Which is foreshadowing for university, where you can do courses in algebraic geometry, which is a combination of the two, but not quite this sort of geometry. What have we got onto? Oh, parallel lines are parallel if they have the same gradient, and they're perpendicular if and only if their gradients multiply to give -1, which is a good fact. That's particularly good if you are thinking about tangents and normals to a curve. We talked about tangents on the integration and differentiation episode of this live stream a couple of weeks ago, video on YouTube. And sometimes you want the normal to a curve, which is a good thing to use would be the idea that the gradient of that is -1 over the gradient of the tangent. Those numbers would multiply to -1, so I'd have to say -1 over the gradient of the tangent to get one from one to the other. Okay, I think I've got some circle facts for you before we move on to some other questions. Yeah, we're still doing questions from chat. Lasjoma from Twitch says hi, so hi to Lasjoma from Twitch. And there's a question about so the pens go with the wipe clean. You get given a pen for the thing in the test center. They're very good. Doing it in test centers means we've got this we've got more of a standardized experience. So whereas before doing things in people's schools meant it depended a little bit on what sort of room your school had to do a test, or what sort of, can the school lend you a pen? It's not something Oxford can comment on, but having it in a test centre means it's a lot more standardised, and we can do things like make sure that everybody has the same sort of whiteboard pen or something. Negative reciprocal, yeah, that's a good one. Combination of words. Do you need to know properties about, this is the best question I've had today, let's put this on screen. Do we need to know properties about random shapes like rhombuses and kites? I'm going to say no. I think you know the names of shapes, right? We've done a question about an irregular hexagon before, so it's probably a good idea to be aware of words like hexagon and ideas about regular and irregular shapes. I think I'd expect people to sort of know what a trapezium is, but probably if we did a question about trapeziums, we would explain what that means, probably, because you might not have seen the trapezium rule, so you might not have seen trapeziums in A-level or equivalent. But there's some stuff that's just sort of, people just become aware, right? Yeah, let's get chat out of the way, because Carlitos wants to know about formulas for circles, and I've got a few. I've got an equation, if you want to describe all of the points that are on a circle. And if you remember back in the curve sketching part of the MAT Livestream, we talked about how sometimes you're sketching curves like this, where you're given y as a function of x, and sometimes when you're doing curve sketching, you're given an equation like this, where x and y are on the same side, and you don't need to rearrange it. You can start looking for solutions, and there's this lovely link between solving the equation means looking for values of x and y that satisfy it, and then sketching that means showing me a picture of where all of those solutions are. So this is kind of, again, a link between solving the equation, finding all the pairs x and y. I'm saying pair x and y because those numbers would go together to be part of a solution together. Like x equals 2 on its own, it's not a solution. A pair of values might be a solution. So somehow this is an equation for x and y. And it's got lots of solutions. There are lots of points on a circle. The solution to this equation is that the points lie on a circle with centre AB and with radius R. Which, if you try and make... There's this game you can play, right, to try and make true facts sound weird. So if you look at this equation and you say, well, there's an equation with lots of squares in it, and you might think you need to use the quadratic equation or something, but actually the solution is just a circle, the roundest thing. It's a game to play, to take true facts and make them sound weird. Gets you better at recognizing familiar things in unfamiliar situations. Let's talk about circle facts. I've put some of them on here. I think all of the important ones, for example, tangent and radius are at right angles if they all pass through the same point, which these ones definitely do. And the angle in a semicircle, Thiele's theorem. I just think this is a really good fact. There's the centre, there's a diameter, there's a semicircle, you get a right angle. Wow. ACB, it's a right angle, like that. Yeah, okay. There's something about how large a circle is, what its circumference is, and then hopefully we can work out some of the circle. If you have angle, down here, angle theta, then you get some of the area, and you get some of the perimeter in kind of proportion to theta. The larger theta is, the more you get around the outside. Yonad in chat has given us x squared plus y squared plus 2gx plus 2fy plus c equals 0, which is a complicated looking quadratic equation in two variables, but wait, that might be a circle in disguise. It's a fun game, isn't it? Let's play that game in the revision questions. I think it's time for some revision questions. Here they come now. For those of you who have seen the questions in advance because you checked the MAT Livestream page before now, you might have preferred questions that you would like us to look at. Otherwise, I'm going to show you some questions on the board and take questions from chat. What is the normal? So the normal to a curve is it's the line that's at right angles to the tangent at that point. Did I say normal here and I meant radius? Oh, sorry, chat. Did I say normal for a circle instead of radius? That would have been really silly. Okay, some suggestion that I used the wrong word. Circle equation in higher. Oh no! Whoa. Okay, I thought Yonad was trying to catch me out, but actually it's a fact that they just see in Scottish Higher. Maya's got some requests. 11, 12, 13. Okay, other requests. I did say radio. Okay, good. Thank you. Got me worried there. Okay, so people who have seen the questions for the first time now, let's have a quick look through. I put some revision questions in about adding together vectors. I'm drawing a diagram of this. If you enjoyed the pirate treasure section half an hour ago, you could draw a treasure map for me in questions 1, 2 and 3. I've said for me, there's no way for you to hand in your work for this, so I won't get to see your treasure map. I didn't say anything about multiplying vectors. Maybe I should have said something about multiplying vectors. you can multiply a vector by a real number by multiplying each of the components by a real number. This is good if you want to scale something up. If you think back to transformations, it's like scaling in the x direction and scaling in the y direction as well. So that sort of multiplication maintains the same direction but doubles the magnitude, or multiplies up the magnitude, sorry. Shouldn't assume that you're multiplying by 2. There's some questions about equations of lines for practice. There's a question about a square. 4 points show they're on a square. 7 is a bit open-ended to find 3 lines given equilateral triangle, all the sides the same length. I thought that'd be fun. More circle questions. Oh look, and then in question 9 I've got this thing which, if we're continuing to assign nationalities to equations, then I'm going to think of this as a Scottish way to write the equation of a circle, because I've been told that that's on the syllabus in Hires. This is maybe a slightly daft thing for me to do, to assign nationalities to different bits of notation, but we're off and away. We've got Spanish vectors, we've got Scottish circles. It's a lovely international feel. Why was it Scottish? Because Hirad in chat said higher SQA, and that's Scottish Qualification Authority. They're telling me that in Scotland they learn that sort of equation represents a circle. Good. Okay. How similar are math questions to interview questions? That's a good question. It's a request for me to talk about interviews. Let's quickly look at the rest of these. There are some area questions down here, which are, question 11 is quite hard. It's the intersection between 2 circles, which is famously a very difficult GCSE question. So, you know, when every year there's a GCSE exam, and for people in the UK, and every year there'll be one question that everyone hates, and recently it was this question about circles, which is pretty much question 11 here on the revision. Then 12 has got trick, and 13 is a sketch graph. Good. Okay, so we'll talk about some of those in a second. Let's talk about interviews. Should we talk about interviews? So interviews are similar to MAT questions in the sense that a long MAT question might have one idea but several parts of the question, and you might need to explain what's going on during that question. That's how interview questions work when I'm doing interviews. There are maybe 100 people who do maths interviews at Oxford, and we've all got slightly different styles, but the idea is usually that we're doing a maths question together, and there's several steps, and I would like you to do as much as you can on each step, with maybe some help from me, maybe some hints. I might give you sub problems to break it down a little bit if we need to, and quite a lot I might ask you to explain why you've done something, or explain why something's true, to try and make sure that you've got opportunities to say why something is true, to say something kind of intelligent about the things in the question. I'm trying to put you in a position where you can say something about what's going on. And if you don't say something, I might prompt or change the question or ask you something different. But overall, I'm not trying to catch people out, kind of the opposite. I'm trying to catch people in. That's not a phrase. I'm trying to put people in the kind of position where they're set up to say something or have an idea. That moment where there's a confusing thing and then you think, these things are at right angles, we can use that, and then you get to do it. We will do that in a second. There's a bit of this in math interviews. Sophie's asked about philosophy. So for math and philosophy, candidates can apply for math and philosophy. Interviews are usually separate, where they might have a math interview, very similar to the other maths candidates, and a philosophy interview, talking about ideas from philosophy. We don't expect people to have formal study of philosophy. We don't expect people to be experienced at debate or something, but might be diving into kind of issues behind a definition. So you could have a conversation about what is a number. Like the interviewer might have an idea to what does it mean to blame somebody? What does it mean to prove that something's true? And we might have a discussion on that to talk about your ideas and maybe try and challenge each other's ideas a bit. I haven't been in very many philosophy interviews. And then 2 questions. What about CS? It's very similar. Computer scientists do actually quite similar things. There's that's a lot of maths in the computer science degree. And a question about physics, or no, a question about maths, but also physics. They want to know if there's going to be physics questions in the maths interview. Unlikely. I've asked people about mechanics before, but I've given people a lot of help with the mechanics. And again, I'm trying to get people to succeed. I know that most people don't really like mechanics very much. So my mechanics interview question in the past was, I tell people the fact about mechanics, I give them a setup. The idea is that they use the fact to turn the question immediately into a kind of algebra, differentiation, calculus, pure maths kind of question. But I think it's good for you to be able to do that conversion, to say, here's a given fact and a situation where it applies. Right, okay. That's interviews. We have a bonus live stream about interviews in November, so months away, close to interviews. I'm talking about some interview questions that I've used in the past, things to look out for, and ideas about what we're trying to do. That was a nice segue. I think that's given time for people to tell me which questions we should be doing, which are the ones on the screen. But first, the tricky one about equilateral triangles. Nobody wants to know about squares. The strat for the squares, question 6. Nobody asked for it, but I think there's different strategies, so I want to talk about it quickly. You know lots of things about squares. It's not a brag, just you do. You know, for example, that they've got all 4 sides the same length. So maybe when you saw this, you thought lengths. That's one idea. But be careful, because not everything with all 4 sides the same length is a square. You don't have to know the name for what it will be if it wasn't all the same, but I think you should be aware that it might be something else. It might be floppy, right? The sides might go in and the edges might come out. Don't expect you to know that's called a rhombus, but hey. You might also check some angles. And note that if you just check the angles and they're all right angles, then it might be a rectangle. So watch out for that as well. Okay, good. Checking shapes. That's right, good. Okay. Good thing in chat claiming not to know about shapes. And since it's a geometry live stream, I really feel I should teach people about shapes quickly. This one, all 4 sides the same length. All 4 sides the same length. But the angles are not necessarily right angles. They might be, or they might not. It's called a rhombus. If you'd like to see some examples of them, we've tiled outside of the front of the maths department with rhombuses, or rhombi, because that's the shape that the Penrose tiles are outside the front of our building. They're all these. Right. What are we doing? No dot product. It just says dot product question mark in chat. No. You can use it if you like. Oh, I suppose, yeah, you could use it for this question if you wanted to. Didn't think of that. Yeah, okay. If you want to revise dot product, I can't stop you. It's a good strategy, I suppose. Some people in chat don't know what dot product is, and that's fine. I mean, you'll learn about dot products very soon. It's good. Very good. It's a way to multiply vectors. You'll enjoy it. Okay, so we're looking for 3 lines that bound an equilateral triangle. So kind of there they are, but what are they? Working out equations of lines. This is tricky, I suppose, because there's lots of equilateral triangles. You've got some choice about where you put it. It's an open-ended question. We don't really do open-ended questions on the mat very much, but I thought it'd be nice to do one here so that you could have a practice. I think for me, I'd put one of the lines as the x-axis to keep things easy, and then I'd try and find this point here. Because if I can find this point here, by which I mean the point that's at the top of the triangle, if I can work out where that is, then I've got for myself a bunch of questions to find the line that goes through a pair of points. Oh, what are these? I suppose I want this to be like 1, 0, minus 1, 0, something like that. And then maybe I'll have this in the middle somewhere. Somewhere on the y-axis. Then there's kind of several steps I can do. I want to work out where that point is. I might think about lengths for an equilateral triangle. I might think about angles for an equilateral triangle. It's got some 60-degree angles in. Rise over run, something to do with tan of 60 degrees. Let's draw that on the picture, just because It's quite a lot to visualize, wasn't it? Something like, there's the side of the triangle I'd like. Something like rise over run is something to do with tan of 60 degrees. And I know the adjacent side is 1. Is it 0A? I always get that sort of thing wrong. Thank you. I did put 2 question marks on it. Thank you. Who is that? That's Sophie. Yes. Well done, Sophie. Maybe well done is a bit strong. Sorry if that sounded patronising. Good job. I'm just grumpy that I made an obvious mistake. I think so. 45 minutes this time before I made quite an obvious mistake. I got them now into the open day and saw the Penrose tiles as well. If you scroll back through chat, there is somebody just before we went live asked about the Penrose tiles, and I put a reply with a link to a video of the tiles being installed. It's a time-lapse video. You can watch it at double speed if you want even more of a time-lapse effect, or at half speed if you want more like real life, less like a time-lapse. Anyway, right, good. Okay, so I've got to find these lines, I've got to find this point. I think I've been stalling for time, but I think that might be root 3. And then I've got a line that goes through here with gradient root 3 that goes through 0, root 3, or maybe it goes through this point over here. It's the point I had before. Where's my equation from before? For a line that goes through there with a known gradient. It should be, so this line on this side is something like gradient root 3 x plus 1. And then, some sort of symmetry maybe. I want a line over here that is something like, has gradient minus root 3. Do I mean that? Yeah, it's coming down by root 3 over a run of 1. X minus 1, I think. So that it goes through y equals 0 when x is 1. I'm quite slapdash with this. How to use trig to model coordinates? Well, in a way, do we need to know how to use trig to model coordinates? In a way, you can switch between the two, right? These pirates who are going off on their adventure, that was 4 and 3. If you draw that, then you can mark in this angle and start to talk about the angle alpha, right? That there's quite a natural link between those distances at right angles to each other and all the stuff that you know about right angled triangles. So I've got this way of switching, I suppose, from coordinate stuff, thinking about triangles. I know there's a 60-degree angle. Here it is. I can see a triangle in the picture. Start thinking about triangles. I think maybe one of the main things that I'm trying to talk about today then is switching between different topics, jumping around. Carlitos asked about virtual open days, and we did one earlier in April. If you're applying next year, then we're probably going to do another virtual open day in April next year. If you're applying this year, then I mean you could find the live stream videos that we did, although they're just on this YouTube channel somewhere. Part of the fun of the live open day though is more the kind of live experience. That the video of watching other people ask questions live is probably not as interesting as being there and asking a question. If you want to ask us questions, there's a contact email in the YouTube description, putting it the website. There's a contact link on the website if you prefer, or you're welcome to ask questions now. Yes. Could you integrate the section? Oh, what an approach. It's certainly an option if you know about integration. What is this? So this is a circle with radius 2 at the origin, and then there's another circle with radius 2 at a displacement 2 along. It's been translated by 2 units. It's silly. Obviously you looked at the second circle and you just knew where its centre was, but I'm saying translated because I'm still thinking about graphs and transformations. Those are 2 of the best circles I've ever drawn. They're really good. Right, okay, we would like the area that's inside both circles. A couple of ways to do this. You can split it up with triangles and bits of circles. The problem is it's got these 2 curved lines. So you could do integration if you're really good at integration, and actually if you know some integration techniques that aren't on the MAT syllabus. Integration bad. Says top comment in chat at the moment is integration bad. Circles, circles are a bit nicer than that, right? So if I mark in a triangle here, one strategy we could have is to find the area of this triangle and the area of these kind of curved bits. It's kind of ice cream model of how to find a chunk of a circle, where you've got like the triangle for the cone of the ice cream, and then this top bit up here for the not very generous helping of ice cream on the top. Delicious purple flavour. If you think about it like that, then pink plus purple is part of a circle. So pink plus purple is part of a circle, something to do with this angle, part of the circle, whereas the pink is just a triangle. So we know facts about triangles, we know facts about circles, it's going to be okay. I think for the purposes of this question, everything is the number 2, right? This is 2, this radius is 2, there's another radius 2 in here, everything is 60 degrees. So I think it's an equilateral triangle. So we've got, this is part of a circle. And if we subtract the triangle, we'll get just the purple bit. We want, what's the order then? We want, allowing for the bit below as well, we want 4 of these plus 2 triangles. That's the plan, I think. Part of a circle, triangle. I want the difference between those to get the purple area, 4 of those and 2 triangles. And each of those is an exercise that you can do. 60 degrees is 1/6 of a circle, so this is not just part of a circle, I could say that's 1/6 of a circle. I know the radius is 2, so it's sort of 1/6 pi 2 squared. The triangle is, I guess, a little bit harder. Well, for me anyway, I can't remember how big equilateral triangles are, so I have to work it out every time. Was it √3? Yeah, √3 or something. Okay, so 2/3 but times 4, so 8/3 or something. Minus a couple of triangles. Something like 8/3 minus 8/3 pi minus 2√3. Yeah. Okay, not particularly excited in what the number is. I should have shaded the bottom half of the circle as well. I was trying to make a point about how I was splitting things up, but maybe it would have been better if I'd shaded this as well to make it clear. How can you integrate this? If it's too off topic, what is it called? So I can Google. Okay, problem with integration here. So when some people look at this shape, they see 4 of these that are all the same. That's terrible. I'm having another go. And it's also, luckily, it was terrible, but it was off the bottom of the screen, so you didn't see it. Quick bit about integration, because somebody asked. When some people look at this, they see 4 of these shapes, where this bit here, not the right angle, this bit here is part of a circle. And I think their plan is to integrate from 0 to 1 the equation of the second circle, or something. I'll say 4 minus or something. And this is not easy. I think I'm putting it lightly. This is not easy. To do this, you would need to do some sort of trigonometric substitution, I think. Yeah, pretty sure that's how I would do it anyway. Because of the square root, it's a bit nasty. And rearranging the circle to get an expression y equals is pretty nasty. Remember, we had the equation of a circle, and we said, you could start thinking about this like this, right? You could bring everything over on that side and square root it to get this bit of circle. It's very unpleasant though. Where was I getting the √3 from? Oh, how big's a triangle, right? So here's my little equilateral triangle. I did this way too fast. Little equilateral triangle? I think that's just the size of the equilateral triangle. Everything's 2. So if you split it in half, then you get 1 down here. It's got height, well, it's a bunch of 60 degrees and stuff, isn't it? So it's got height √3. And then the area of the triangle is 1/2 base height. So 1/2 √3, 2. Which which is root 3. And then I'm subtracting 4 of them and adding 2 of them back on. So yeah, where is y? Yeah, sort of inside. Integrate with respect to x. Don't love it. I think it's too much work. Okay, 5 minutes before I think we should move to some math questions. Let's talk about 12. If you want the graph for 13, I would accept slow growth, then so quick growth, then slow growth, then slow again. Some sort of question about moving one circle on top of another one. Oh no, moving one circle into a region. Yeah, it's the eclipse question. Anyway, the trick for 12. I don't love it when people say trick for these, but I mean, I wrote this question, so maybe it's okay for me to call it a trick question. Something quite dismissive about calling things trick questions. The trick here is that if you think about these two lines, 1 and 2, if you think about these two lines, they've got gradient, and this one's got a gradient, and then if you really think about it, minus 1 over a, I think. If I've got all the minus signs right, it's negative. It's kind of 1 over a because it's the change in y's. Yeah, I have to really think about it. As it comes down, it loses a value of 1 over a across the 1 there, which means that the gradients multiply to minus 1, which means that there's a right angle here, which means angle in a semicircle, diameter. This is the diameter. The trick here is to discover the right angle and then recognize Thales' theorem, or possibly this is the converse of Thales' theorem, I'm never sure. It's a trick because I'm trying to take the thing that you know about things at right angles having gradients having gradients that multiply to minus 1, and I'm trying to ask that the other way around, to show you two random lines and see if you can spot that they multiply to minus 1, and therefore there are right angles. There's an if and only if in that statement. Yeah, good. Okay. Could you draw a rectangle as both circles same around the shape, but subtract half the circle? 2. No, but it's complicated, isn't it? That's a suggestion of another way to find the area, and I suppose if you've got a different method in mind, you can try it. And if it gives you 8/3 pi minus 2 root 3, then maybe, and if not, then maybe not. Oh, I did this as a question once. I don't think I'm doing it anymore, but at some point I had a question about this sort of Venn diagram, right? It's too much work. But you could do this kind of Venn diagram where you might want these things to have equal areas, so that 1, 2, 3, and 4 all have equal areas. Hard question. How do you do that? How do you put two circles over the top of each other so that the middle bit is equal in size to the outside bits? And then how do you put a rectangle around that? How do you put a rectangle around that so that the outside bit, oh no, the outside bit, same area. That's what you've made me think about by asking about a rectangle around two circles. You know, so that you can make a perfect Venn diagram picture where all 4 regions have the same area. Because then you can throw darts at it and choose. Anyway, never mind. Did I finish this question for 12? I sort of gave you the punchline, or the idea, which is, oh, there's a right angle here. If you're asking about the circle, and there's a right angle there, and you found the diameter, the centre is at the midpoint of the diameter, it's halfway up. So a plus 1 over a over 2. Which is a bit much, really. If you have 3 random points, there is a circle that goes through those 3 random points, provided they're not collinear, but it's quite a lot of work to work out what the circle is. Could you use this problem on circles in probability with Venn diagrams? Hot take, I don't think Venn diagrams tell you anything interesting about probability. Come at me, Venn. Gonville and Keys has joined chat. Right, okay. Yeah, I'm 13. I think I'll just give you a picture. So as the circle gets close, nothing happens until the circle gets close enough that there's a little bit of it inside positive x, and then the area increases until you get to the other side of the circle where there's not very much area, so it slows down. And then once the circle's inside, you've now got all of the circle in x positive, so then it becomes flat again after some point. But there's this kind of fast, slow, fast growth. Okay. Draw a rectangle as both circles the same around the shared bit, tangent to each of its edges and half minus circle. Where's the rectangle? Around this bit? I don't know about half the circle. Oh, because that's the middle. In the question, that those go through the middle of the circles. So your plan is to draw a rectangle like this. It's tricky though, because what about these? Sort of equally tricky. I don't know the area of these kind of curvy bits with up here. Where did that come from with 13? Oh, just tried to visualize it in my head of how this circle moving into x positive. What would happen? So 0, 0, 0. Much later on, 1, 1, 1, or pi, 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 or whatever it is. How big's the circle? Radius 1, pi, pi, pi. In between, as it's crossing over, there's this initial bit where you get some area. As it moves, the area's gonna get larger and larger. When you get to the halfway point, start slowing down. The area's still going up, but now less and less, because each time I move it a little bit, the circle's a bit skinnier over there, less tall perhaps. So as I post the next bit in, I'm giving it less area on the right hand side as I move things in, which is why I've got it slowing down after this point. So after the halfway point, loads more. But then over here, I've got it slowing down again. So as the last bit comes in, that's not very much area at all because the circle's not as tall over there. In general, if you're passing a shape, oh goodness me, the whole visualization was off the screen, wasn't it? Some of it was off the screen. As I pass it through, I've got less circle. For the last bit, I've got less circle over there at the end. Okay, not a very exciting question. The graph is, I don't remember why I asked this. It's not interesting. It's kind of based on intersecting circles again. If you've got two circles that are moving past each other, then it's kind of pretty similar to question 11 in some way. How would you actually calculate it? I guess you'd have to mark in a lot of circles and think about arctan and stuff. It would not be very fun. If you wanted that area over there, it's that ice cream thing again about having a sector of the circle, or is that a segment? Now I've got to get it right. Yes, GCSE, sector of a circle. The sector of a circle minus a triangle. So something to think about there in terms of, in general, as this angle changes. And then I suppose also that angle depends on where the circle is, so not very fun to think about. Okay. There's a description in chat. You get an increasing rate of change as the centre approaches the y-axis, since more circle is entering at each increment. Yeah, I like that. Thank you, Calla, in chat. Let's have another visualization. Slow-mo replay. Here it comes. How much area is in there? Almost none. Still basically none. Oh, this circle is so tiny, I don't care. Wait, some large bits of circle are coming in now. I'm interested. Area is increasing faster because we're posting in large bits of circle. And now, well, the drama is over. We're now posting in small bits of circle into the positive x-axis. And now we're posting in nothing. Right, good. Anyway, it's a vague description. Here's a question about a circle. We're moving on to math questions. Let's go. The way this stream works is we do about an hour looking at the content, and then we do some actual questions from past math papers. Good way to practice math questions, isn't it? Here's a question about a circle, written in the Scottish manner. It's not going to catch on, is it? I don't think I can. I'm going to have to explain it every time I say it, because one person in chat told me that they're in Scotland, and that's something that they recognise as a circle. make sense, does it? Doesn't make sense as a thing for me to say. We would like to know whether the origin is inside the circle. Origin? Is this inside the circle or not? And you might wonder, where is the circle? I've drawn it over here somewhere. Depends on A and B and C, doesn't it? C looks like it has something to do with the radius. It's probably not actually the radius, but C has something to do with the radius. C has something to do with the radius, and A and B probably have something to do with the position. And maybe it's some complicated mix of those things. Any suggestions in chat? Maya's off. Bye, Maya. Let's look to chat quickly for suggestions about how you'd get started with this question. What are we going to do? We're going to do a couple of multiple choice questions, I think, and then I would like to talk about a long question. I might jump between them, actually. Yeah, I might jump between them. Mix it up a little bit. We've got several conditions here. While you're thinking about circles and whether or not the origin is inside this circle, I'd like to draw attention to the phrase precisely when. That phrase is there to give you a kind of sense that this should be an exact condition that works if and only if the origin is inside the circle. If the condition holds, the origin is in the circle, and if the origin is in the circle, the condition holds. It works both ways. 2 suggestions. No, wait, 3 people in chat want me to complete the square. So I guess do as I'm told and complete the square. If I do that, then, well, this is not going to be quite true, is it? This is me getting the x coordinate, the x component right, and the y components right. What do I mean there? A coefficient is what I mean, isn't it? Getting the coefficient of x squared correct, getting the coefficient of x correct, but the constant is going to be slightly off unless I add a squared over 4 and b squared over 4 to both sides. I mean, I've included it already on the left. That's a bit cheeky of me, isn't it? Probably I should subtract a squared over 4 here, subtract b squared over 4, leave the right hand side alone, and then separate line, move those things onto the right hand side. But I'm moving fast and breaking things. Yeah. So I like Sophie's expression in chat. If you're in Slido, thank you, Sophie, for typing that. That's exactly the thing that I sort of skipped past. Ooh, difference of 2 squares. That's a suggestion I haven't seen. But then what Anna's actually done, I would describe as complete square. Yeah. So then I guess the question is, we've got this, we now know where the circle is. The centre is perhaps weirdly negative a over 2, negative b over 2. And there's a radius on it, which is something like square root of all of this. But we'd still like to know whether or not the origin is in there. So there's some test we could do to check whether the origin, the distance between the origin and the centre maybe, to check whether the origin is close enough, to check whether the distance is less than the radius. It was just a typo. I got really excited about difference of 2 squares. I like the difference of 2 squares, but it's just a typo. One day we'll take the difference of 2 squares. Good. Okay. Yep. Okay. So I think people are going to write down the expression for this distance, which I'll call d just for fun. They'll find that it's a squared over 4 plus b squared over 4, square rooted. And then they'll compare these expressions and discover, aha, this is true exactly when c is positive. If c is positive, then this radius is larger than this distance, and if c is negative, then it's smaller. Good. Aha, and there's a different approach in chat from a couple of people coming through now. They've had time to type their other approach. Let's have a quick look at chat. Sub in x and y equals 0 to get a value for when the origin lies on the edge of the circle. This is an idea that I quite like. This is going to ruin my diagram slightly, but I'm going to imagine changing. Oh dear, that has ruined my diagram. Can I adjust the circle? No, the circle is now connected to some of the drawing. That's fun. Sometimes I feel like Miro has too many features for my tiny brain. Okay, here we go. We can make the circle larger or smaller, and there's some sort of perfect value of c. I guess I'm imagining that c is something to do with the radius. It's kind of this perfect value of c, where if c is large enough, the radius is large enough that, ding, the origin lies perfectly on the edge. And then if you make c larger than that, the origin is inside the circle. So if you make c smaller than that, no, it isn't. Perfect value. And that perfect value comes from when the origin lies on the edge of the circle, the kind of threshold or dividing line between the inside and the outside of the circle. And that happens when 0, 0 lies on the circle, which is when 0, 0 is a solution to that equation. Remember, a pair x and y, a pair of numbers x and y for the coordinates, that's a solution for those numbers together. Here, if they're both 0, that's a solution provided that both sides are 0, so provided that c is 0. Okay, so there's this other strategy where you find out when the origin is on the edge of the circle and think about inside and outside. Okay, good stuff. Good job, chat. We're going to switch to a couple of pages down. If you're playing along at home, I'm going to turn 2 pages to go down to a kind of similar looking long mat question, because I want to talk about that. Something in chat is highlighted, which is how there's a student moderating chat, and highlighting is how the student gets me to look at things. Subject x and y gives a value for c. This gives an equation where the origin lies on the circle. Then I imagine that area covered increases with c. Yes, that's the thing that I thought we were doing. Good. The second solution. Thank you. I've seen that now. Ding. Okay. We'll come back to a couple more of these questions, I think, but I want to talk about this. So if you're playing along at home, I've turned 2 pages past the hints. That's right, you get hints if you look at the worksheet ahead of time. You can read the hints before I spoil all the answers on the live stream. Here's a circle that goes through the origin, so kind of related idea for this long question. A circle that goes through the origin, and it goes through these points P and Q. And this question gets us to do something slightly different, which is to show that the circle has this equation, x squared minus px plus y squared minus qy equals 0. And there's that 0 on the right hand side because the origin is on the edge of this circle. So I suppose the question here is, how are you going to find out the equation of that circle given the information that you know? I mentioned in passing that given 3 random points, finding the circle that goes through those is pretty hard work. That's exactly what this question is getting you to do. It's giving you 3 random points and it wants the circle that goes through them. Yes, oh, so just to wrap up that short question, it was A. C should be positive, so it's A. Good, which I think is where people got. Thank you to Keller in chat, who is trying to make the Scottish equation catch on as a phrase. Should probably check with her whether this is it okay for. Well, it's a slightly different expression. Okay, so I think my reasoning for this, to explain why that's the equation, would be something like writing down a general expression for a circle. We know that C is a circle, so write down a general expression where I don't know A, I don't know B, and I don't know R, if those are the centre and the radius. We're going to find those quite quickly through this question. It says find the centre and the area. So perhaps I'm trying to solve for A, B, and R. That's 3 unknowns: the centre, coordinates, and the radius. And I know 3 facts. I know that the circle goes through those 3 points, O, P, and Q. So that's a reason to be optimistic. I've got 3 unknowns and 3 equations. And I'm saying equations, even though they're geometric points, because we're translating between an idea that that's a geometric problem versus equations, that the coordinates for those points should actually satisfy the equation. Again, when you sketch a curve or draw a circle, you're showing the solutions to an equation, the points x, y that satisfy that equation. Okay, so I've got to do this weird split screen thing where I do that and try and talk about the circle at the same time. So I'll draw my own version down here. Sorry, this is a little bit wonky. Here's the equation that I was saying out loud. Zoom this out a bit. And it goes through the origin, p comma 0 and 0 comma q. Okay. And those are three equations because they all lie in the circle. So my equations are something like a squared plus b squared equals r squared, to say that 0 goes through. And then I've got two more to say that p plus a squared plus b squared equals r squared, and one more from that point up there to say that a squared plus q minus b squared equals r squared. And then I just have to solve those, which is not as bad as it sounds, because when you multiply out this square, you get a squared plus b squared, which is also to r squared, so lots of stuff cancels. You get p squared plus 2a left over here, and you get q squared minus, ooh, do I want plus signs? Maybe I want plus signs. You get q squared plus 2qb left over in this equation, which gives you expressions for p and q. And then all of chat is going to tell me that I've missed a trick, haven't I? I've missed a trick. I've missed a trick that there's a right angle. There's a right angle in this triangle on the axes, which means we've got Thales' theorem. We've got a right angle in the semicircle, which means that this is a diameter, which means that the midpoint of the diameter is the center. It's precisely the thing that I called a trick question 20 minutes ago. It's turned up to bite me. It's come back. Well done, chat. If you spotted, there you are in chat. You can go on screen quickly. QP is the diameter, so that's the midpoint, from which you can work out the radius and the area, and you know where the center is. I was very happy about having a load of equations, because it let me make my point, the point that I've been making about circle equation, geometric circles being, you know, related concepts. But now I see I've missed a trick for right angle in a semicircle. I should stop calling that a trick. It's a very good fact. Right, okay. What should we do next? We could do more of this question, sort of having fun. We could prove that the area of the circle is at least pi times bigger than the triangle, or we could prove that the area of the circle is equal to twice pi times the area of the triangle in a particular case. Both of these turn into algebra questions really quickly once you know P and Q once you know the facts about the circle in terms of P and Q. So at the moment my circle has A, B and R in it, but if I solved these equations, then I would know everything in terms of P and Q. The numbers in the question are P and Q. I invented A, B and R to describe the circle. Ideally, I'd like to say everything in terms of P and Q in the question. If you do that, then lots of stuff becomes easier. For example, I mean, the area of this triangle, this right angled triangle, is just PQ over 2. So everywhere it says area of triangle OPQ, they just mean PQ over 2. And the area of the circle is something else to do with P's and Q's. So there's a calculation that you do there, and then this turns into an algebra question, and there's an inequality in the first bit there, so some inequalities. More of the same question? Anna says both. Okay, we're going to do both. Having fun. Right, okay. So I think I need to finish off this calculation. I regret not just using right angle in a semicircle. I think I'm going to go for this. Okay, so I'm going to finish off my calculation I was doing over here. 2pa, and there's an a squared plus b squared, and on the right there's an r squared. I hope people will be okay if I just put 0, because I know that a squared plus b squared on the left is equal to r squared. That's a good fact. And this one says that q squared, sorry for the handwriting. Handwriting has actually let me down as an A. Q squared plus 2qb is equal to 0. Because again, I get an a squared and a b squared on the left, but that's just equal to the r squared, so I'm going to cancel them out. Okay, so then getting a in terms of p is something like a is minus p over 2 for me, b is minus q over 2. So I've discovered the fact that the centre of the circle, which I've written in this very strange way, I put plus signs in. I don't think I should have done that. I think I should have done minus signs. That's how you do the centre of a circle, isn't it? You put minus signs in. Are you shouting at the screen that I should have put minus signs in? Yeah, there we go. I should put minus signs in. We're not counting that as a minus sign error though. Just a minus sign poor decision. Right, okay. The centre of the circle then is at p over 2, q over 2, the midpoint of that line, and the area, you see, write down p over q, 2 over q, you think, oh yeah, it's the midpoint of the line, it's halfway. The area, I'll need the radius, and that's a squared plus b squared. I have this equation for r squared. So I should square both of these things. Okay, so we've got to the point where whenever we see the area of the triangle in the question, we know it's pq over 2. And whenever we see area of a circle, we know that's pi times p squared plus q squared all over 4. So what does the question want us to prove? It says show that, and then I'm just going to translate the thing in the question into the things that I've got in the expression. So I show that. I'm going to bring out that factor of 4 as well. I hope that's okay. P squared plus q squared over, and then down here, pq over 2. Show that this thing is greater than or equal to pi. Which I suppose, if I simplify things down a little bit, is like being shown. So I'll put equivalently. You know, this pi is not doing anything on both sides, is it? And there's a factor of 2 around here that I don't love. So equivalently, we're asked to show this thing. And I know it looks a little bit dodgy that I've got rid of the pi's, but I mean, if this is true, then I can multiply both sides by pi. And if this is true, I can divide both sides by pi. So these are kind of equivalent statements. And pq's not 0. So we're all okay. Nobody's dividing by 0 around here. When you've got a statement like this, there's several ways you could prove something like this. But I think the easiest is to treat it as a kind of algebraic expression. Fractions are hard. Multiplying up your fractions is probably good. I think we're told in the question they're positive numbers. So equivalently again, or even, this is also equivalent. Something like this, which, where have I seen things like p squared, q squared, and 2pq? I've seen those from multiplying out a square. Multiplying out p plus q gives me all of those things, but not on different sides of the equation. Let's bring this over on the left so I can get a closer look at what we've got. If I bring this over on the left and put it in the middle, this is p minus q squared, isn't it? Which is true. And I'm not just bluffing because squares are positive. Because is one word ahead. Squares are positive or 0. This is a sort of way of moving it towards something where you can recognize it in terms of algebra or a fact about inequalities. Moving in that direction is probably a good idea. Technically, for mathematical reasons, I should probably reverse all of my steps as well, or explain that you can reverse this to sort of start here and then work through the lines in that order until you end up with the thing in the question, but my word equivalently is doing quite a lot of work. Other part on the screen, when is it equal to 2 pi? So let me think, when is, and then I've got my expression again, which I'll put in a slightly simplified form like this. When is this equal to 2 pi? Question mark. That's not the thing in the question, but it is something I want to think about. So that would be the case if p squared plus q squared was equal to 4pq, which doesn't look very true. Doesn't look like it could possibly happen. I suppose this is before I moved it over and it looks like a square. This is sort of happening again, isn't it? Suggestions from chat, please. I've got one suggestion in chat. Let's get a couple. I like to get a couple of suggestions, especially if they're different. I've got an expression here which I don't recognise as being the square of something because it says 4 instead of 2. And the suggestion from chat is that I just solve for, and they've said p over q, that this is a sort of hidden quadratic or secret quadratic. If you divide both sides by q squared, then you get this. Do you remember in algebra or one of these live streams we talked about turning things into a quadratic? So this starts to look like a quadratic for p over q, at which point I can get out the quadratic formula to say that this is 2 plus or minus root 4 minus 1 is 3. Good, okay, that gives me the ratio p over q. I haven't addressed the thing in the question, right, which is angles OPQ, and the angle down here, but now I see that that's something to do with q over p, so I've got expressions. My expressions are not going to be very neat, are they? But I think my expression for this angle, if I call that theta, is that tan theta would be 1 over 2 plus or minus root 3. There's 2 possibilities. Do I mean 1 over? Doesn't matter. Doesn't matter. That's a fun fact. Doesn't matter if I put 1 over there. Can you work out why? I had a panic that maybe I meant 2 plus or minus root 3 instead of 1 over 2 plus or minus root 3. Maybe you can spot why I can get away with that. Anna asks, would thinking about the circle geometrically help? 2 pi is the area of a circle with radius root 2. Yeah, that's interesting, isn't it? That's interesting. Can you find a specific, maybe if you could find a specific example where you could work out the area of the triangle and you knew the area of the circle, then in that example you might say, well, here's an example where I've got expressions for the angles. Problem is, I think that's about 15 degrees or something, which is quite a weird angle. I think the solution might be 15 degrees and 75 degrees. Not required to go and solve this because who knows the values of 15 degrees anyway. But yeah, and here in chat is the answer to the ratio thing. If you rationalize, you get the same thing. It comes back again. 2 plus root 3 is 1 over 2 minus root 3. They multiply to 1 by the difference of 2 squares, or if you prefer to think about factorising your quadratics, they multiply to 1 because there's a 1 here, so they're reciprocals of each other, which means that that plus minus sign is weirdly doing the same thing as if I put a plus minus sign around the whole bracket, but never mind. The plus minus sign is doing a sort of reciprocal thing. Weird, isn't it? I'm going to get distracted by that for a second. We had something like this in logarithms. The logarithms worksheet had something like, so n squared plus or minus root what do I want here? N plus or minus root n squared minus 1. Yeah, this is what we had in logarithms. Okay, it's the return of the logarithm fact with these things in. What do I want to put here? This symbol for like the upside down is 1 over. It's 1 over this. The other way around. They multiply to between them. They multiply to 1 because the difference is 2 squares. Right, good. That was a little tangent from the geometry live stream. What next? It's 6:30. We've got a choice. Oh, should I do a quick poll? Let's do a quick poll. How do I do a poll these days in Slido? Interactions. Add new interaction. They've changed everything. It's very complicated. Let's go multiple choice. What next? And the options are multiple choice question, which is going to be MAT 2017 question 1G probably, or we could talk about the other long question. The other long question is quite a lot of work. That's not me trying to sway the poll, but the question is not straightforward at all. Maybe that's why people will want to talk about it, or maybe people will prefer to talk about multiple choice questions. If I should be so lucky. Okay, if you've been looking at a screen for the last hour and a half, don't forget to occasionally look away from the screen and blink. If you've been thinking about maths and nothing else for the last hour and a half, that's all right. You don't have to blink from that, do you? I'm trying to drink some water to remember that there's more to life than triangles, but oh, there's a lot of triangles in life, aren't there? People are voting for this, just to have this as hints for this question. What was that hint say? My strategy for this part is to solve in the opposite order. Write down an equation of the circle. Yeah, I'm happy with that. Got the minus signs. Got the minus signs the good way around in the hint. Long question is winning at the moment. This is what people are voting for. This triangle circle thing where the height of the triangle changes. The height of the triangle changes. And the question is about the area inside both, which, there's a lot going on there. As h changes, the triangle goes through a few different stages in terms of what the area is. That's winning a vote. I've got to respect the vote, right? Okay, we talk about this. Let's go to the PDF. Here is the setup. I modified this a bit. Oh yeah, I modified to convert it to degrees. This question is old enough that it was written in the language of radians. Modern math questions are written in the language of degrees. So I've converted this one, which has made the solution look a bit weird. Anyway, so here's the problem. There are 3 corners of a triangle, 0, 0, 3, 0, and 1,2h, and it's that letter h that's going to cause us all the trouble, because you see it controls the height of the triangle. Circle C has equation x squared plus y squared equals 4, and there's an angle theta in there, and we're asked about tan theta in terms of h. This is straight up trigonometry question. Please draw in a right angle triangle, because the one in the question is not helpful really. It's not right angled. I would like a right angle triangle to talk about trigonometry. If you do that, then you have something like the opposite side is the height of your little right angle triangle. I'm imagining dropping a perpendicular from the point just off the top of the screen. Oh, there it is. Dropping a perpendicular from that point down to the x-axis so that I get a right angle triangle involving theta. If I do that, then tan theta is, I think, just 2h. I should make a note of that somewhere, shouldn't I? Tan theta is just 2h. Yeah, sounds true anyway. Here's what the question wants us to do. It wants us to think about whether the point 1, 2h lies inside the circle C. There's an inequality for h there. Let's observe that this is similar to the question about whether the origin lies inside the circle from that short question we were doing about half an hour ago. Similar, isn't it? To ask whether that point is inside or outside the circle. An idea that some people tried there was to find out when does that point lie on the circle. When is it true that x squared plus y squared is 4 with x is 1 and y is 2h. Well, if you plug it all in, that point lies on the circle precisely when 1 squared plus brackets 2h squared is equal to 4. I forgot to close the bracket. Exactly when 1 squared plus bracket 2h close bracket squared is equal to 4, which is some expression, right, that you can solve. You can rearrange, subtract the 1, get a 3, take a square root, get a root 3 divided by 2, get root 3 over 2. There's a root 3 over 2. Okay. So that point, as it moves upwards, starts off inside the circle if h is close to 0, and then when h gets too large, it moves outside the circle. Those are the two cases in these pictures they've given us. Large h, small h. So that crossover point comes when the point lies on the circle, which, tiny bit of algebra to plug in the point into the equation of the circle, 1 plus 4h squared is equal to 4 question mark, and it's equal to 4 question mark if h is root 3 over 2. So there's a transition point there. This one was a lot of thinking, says Anna. Yeah, and also something about the proportion for the previous question. Yeah, P over Q is a proportion, so something to do with tangent or maybe cotangent. You could think about the plus minus as representing a kind of tangent cotangent situation as well. Good. Yeah. You want x squared plus y squared. Is that less than 4, equal to 4, greater than 4? Those are the three cases. They turn out to be less than root 3 over 2, equal to root 3 over 2, greater than root 3 over 2. Then we're asked for the equation of the line connecting 3 noughts to 1, 2h. So it's what we've been training for, right? We did all those practice thinking about lines and equations. Joking aside, the gradient here, I would say, is minus, what is that? So to get from the first point to the second point, the change in x is -2 and the change in y is 2h. So the change in y divided by the change in x is 2h over -2, which is -h. This is a new approach where I have the whole question on the screen and I just try and do it out loud. I'm not sure it's going very well. So I'd find the gradient of that line and then send it through one of the points. You've got a choice about which of the 2 points you send it through. I would send it through the easier one, just probably the one that involves the number 0 and doesn't involve the number h. So I'll probably send it through the point 3, 0 to say something like this is y is -h times brackets x take 3 close brackets. Am I onto something? Good, this is going really well. -h for the gradient and it goes through 3, 0. You're going to be okay. And then, that sounds really hard. Show that this line is tangential to the circle. Show that this line is tangential to the circle when h is 2 over root 5. That sounds tough. I think for that one, I would like to draw my own picture. So let's do that. And also because it's a chance for me to switch back to the normal mode of drawing things. Okay. So show that this line is tangential to the circle C. So we've got this line over here and this point up here, 1, 2h, and this line, which might be tangent to the circle or might not be. I should probably draw it tangential, shouldn't I? There we go. Now it's tangential. Okay. So several things come to mind for making a line tangential to a circle. We could find a general tangent to the circle and check whether or not it's this line. That sounds like work. We could find the gradient at a general point. We could try and find the point of intersection. That might be fun. We could try and find out where is this point. If it exists, where is it? I suppose sometimes there'll be 2 solutions, sometimes 1, sometimes 0, depending on, as this point moves upwards, is this line going to cut through the circle or not at all? Are they going to miss if h is too large? So there might be 2 solutions or 1 solution or 1 solution. 2 solutions, 1 or 0 solutions for the number of intersections between the line and the circle. Let's write down that line. I think, after thinking about it for maybe too long, it's this line, and the circle is this circle. So circle and line. Yeah, different approaches. What does chat want to do? Let's ask chat. Oh, I've got behind with chat. Chat's talking about marks. One solution: b squared minus 4ac, quadratic equations. Yep, seems like people want to think about this in terms of equations. Something like, if you're looking for that point with a question mark, you should sub one of these into the other. I'm going to sub this one in because it says y equals, to get something like x squared plus h squared x minus 3 squared. I'm squaring, so I don't care about minus signs. And then this is a quadratic equation. And the question of whether it has exactly one root, exactly one solution, is a question about quadratics that you're quite well equipped to answer, I think. Not a brag, you just genuinely know a lot of stuff about quadratics. What is this? 9h squared minus 4. Is this really correct? I think I've made this more complicated than it needs to be. Am I going to write down the discriminant and solve for discriminant equals 0? I think I might be about to do that, unless somebody stops me. Nobody stops me. Oh, somebody is maybe trying to stop me. Think about this without converting to algebra. Yeah, probably. What's the solution for? What's the method for? What's the method without converting to algebra? Missing a 4 from my 4ac. It's going to cancel the h to the 4. It's going to give me a quadratic in h squared. Maybe not even a quadratic. Just a value of h squared, and if I'm very lucky, the value of h squared will be 2 over root 5. Quite keen to follow that through. I don't think it's what I've done at all in the solutions on the website. I don't think I've done this. I've done a lot of stuff, but I don't think I've done this. The alternative, which you're maybe considering, if you would like an alternative. The alternative is to draw in the radius. It's a thing you can do when you have a circle and a point. You draw in the radius, it means the tangent at right angles, and you already know the gradient of one of these lines. So maybe you know the gradient of this line as well, the gradient of the radius, 1 over h. That's an interesting proposition, because that means that the equation of this line, up here a bit, the equation of this line, this radius, is nice and easy to write down. It's just this. Goes through the origin, so no more writing. Once you know the gradient, 1 over hx, it's much easier to intersect this line for the radius with this line for the potentially tangent line. To do the intersection of those is just solving linear equations, so that's much easier. So if you thought about drawing in another line, the radius of the circle, then maybe you're having a better time than me, because back over here, I'm about to multiply out some brackets at 6:45 on a Thursday, so my chances of success do go down during the week. How many things will I try and blame this on? Let's see. So 36h to the 4 out the front, and then another 36h to the 4 coming off this with a minus 4 outside. The cross term here, I get 9h squared minus 4h squared is 5h squared if there's a 20 out the front. I'm going to try and keep the 4 outside all of this though for these remaining terms, where I get that 5h squared and I get a minus 4 out here as well. Because I know these things cancel, and then I'm going to divide by the minus 4 to get this h squared is 4 over 5. Take the square root, get 2 over root 5. Plus or minus. Yeah. Or, okay. Finished the calculation, got 2 over root 5. Really think I missed a trick. That in here, there's some gradient stuff. Anna's spotted that this has got something to do with theta, which they told us about in the first question. They told us about theta ages ago, and now we know this line's got a gradient 1 over h. It's going to be okay. Right. Good. Okay. I like seeing people thinking about better solutions while I'm doing this. Hannah's come through. I think because of the lag between chat, Hannah has heroically done the same calculation and it's worked out. It's all fine. Up to factors of 4 and 16 and stuff. I know what you mean. There's a 20 or there's a 4 or a 16. This bit is what I'm looking for, I think. Who can even say? We've still got like 2 parts of this question and about 15 minutes. Seems like a good rate. Maybe just call h squared n to make it less complicated. Yeah, that would have been a good idea. That would have been a good idea for me to have about 5 minutes ago, that everything's h squareds. So give that a name, and then I won't have to write h squared, and I won't get scared when I see h to the 4. I will think instead, n squared, a quadratic, I'm happy. It will cancel, and then I'll think a linear term, I'm winning. You know, little things. Right, here we go, part 4. Part 4. I've forgotten the setup for this question. I don't know where we are. Part 4. Suppose h is larger than 2 over root 5. H is so large that the line is no longer tangent to the circle. We're in the left-hand case. I remember a picture on the left. Yeah, with this, theta is so large, h is so large that you're beyond tangent. You know, h is all the way up there. You got no solutions to that. Okay, circle. Good. I like it. Okay. What are we being asked for? The area of the region inside both C and T in terms of theta. Both the circle and the triangle. Well, that's a bit of a circle, isn't it? So if you're all the way up here, then the bit of the circle that's also inside the triangle is, well, it's just a bit of circle, isn't it? This line is so high up that the point h, this point is way outside the circle. Do I know it's outside the circle? There's a lot of thinking, isn't it? Somebody in chat said there's a lot of thinking in this question. I think the point's outside the circle because h is larger than, if h is larger than root 3 over 2, or maybe because h is larger than root 3 over 2, outside circle, and h larger than 2 over root 5 would say not tangent. I think if you follow through the algebra of the previous bit, there's no points of intersection. Quick check, this is root 3 over 4, this is root 4 over 5. So these things happen in a particular order, don't they? First you leave the circle and then you stop being tangent. So if you've got this far, then you're definitely outside the circle. And this one happens afterwards. It's the square root of a larger number, 0.8 instead of 0.75. It's close, but that's the square root of a larger number. So this one happens second as you increase h. Right. There'll be someone out there who enjoys the way that I can't quite say the letter H. I'm much worse with the letter R. I just can't say these sort of single letters. Very tricky for me. Right. A little bit of accent-based humour for you there while I try to remember how large circles are. Yes. You see, I can say the word R. I just can't say the letter. Got a bit of a circle here to do with theta. Is the area of the region just, well, how large is theta? Theta over 360 degrees times, I guess, 4 pi, because the circle is radius 2, so don't forget pi r squared. How much of the circle have you got? I think that's probably enough for an answer, isn't it? 4 pi times theta over 360. Somebody might call that pi theta over 90 degrees, or somebody using radians might have a much better expression for that, I suppose. But yeah, I think that's the amount of circle here. There's something in the revision notes, way up at the top of this doc, in the revision notes about how large a bit of a circle is. Good. Okay, so I think that was a bit of a non-question. Once you've realised that the region you're looking for is just a bit of circle, you have a letter for how much circle, I'll go with that. I suppose I could. I know that tan theta is 2h, so I could write this as pi inverse tan of 2h over 90 degrees. How do I feel about that? Not great, to be honest. Don't love it. What do you think in chat? Chat says, why was radians changed to degrees in MAT? Simple answer. The A-level specification for people learning maths in England and Wales was changed so that not everybody would see radians in time for the MAT. So we ask the questions in degrees now. Chat says, yucky. Right, cool, okay. Chat's not a fan of this, and neither am I. It's technically an expression in terms of h. What does the question say? Oh, the question says in terms of theta. Scroll past that. Let's scroll past that. Okay, now let h be 6 over 7. Quick think. Is that larger than 2 over root 5? It's not obvious, is it? It's really not obvious. It's not obvious at all. I guess I could square it. I don't really want to. I could square and compare. Wait, there's a point on the line and the circle. I think it's not, because there's a point on the line and the circle. And my intuition is if you make h bigger than this, then so not any points on the line and the circle, no intersections for you. So I'm going to go probably not, without doing any calculations. Right. How on earth am I going to show this? 0.8 6 fifths lies both on the line, which a reminder was this, and the circle. So the circle is not too bad because squaring those things, I'm going to get some sort of Pythagorean triple. I think there's a 3, 4, 5 triangle hiding in here. I can see a multiple of 3 and a multiple of 4, and I can see the number 5. I think I can see a 3, 4, 5 triangle. So I'm happy with this one. Over here, this seems a bit arcane and weird, but let's check it. Just seems odd. Starting to discover I have all sorts of opinions about these things. Minus 15, there's negative 7 over 5, the 7's cancel and you get 6. Do I want over 5? Where's my over 5 gone? Oh, it hasn't gone anywhere, good. Yeah, maybe I should square both. Suggestion in chat is that I just sort of, get with the program and square both things up. And then I guess cross multiply to get so compare these fractions, I might multiply both sides by 49 and both sides by 5 to kind of compare them. And then I get 150, 180 versus on the right 4 lots of 49. 4 lots of 49 is pretty close, isn't it? To 200. It's 198. So this thing is larger. So no, it's not. But I didn't enjoy doing that calculation. So there we go. What are we doing? The point lies both on the line and the circle. So I think if I get one good drawing, then the question's done. Is the point inside the circle? I would quite like to know if the point's inside the circle, which is from way ages ago in this question. Is 6 over 7 larger than root 3 over 2? And I think it might not be. Let's find them. So you can multiply both by 14 to do 12 versus 7 root 3. And then do some sort of squaring to do 144 versus 49 times 3. 49 times 3, oh, it's pretty close. But 49 times 3 is 120, 147, which is slightly larger. So this thing is larger, this thing is larger, this thing is larger. Which means the point is inside the circle. The point is inside the circle. Everyone. That's crazy. We've got to find quite a weird area, haven't we? We've got to find quite a weird area. We've got this point, which we know is 8 fifths, 6 fifths. We've got this point, which is 1, 2h. We've got the origin. We've got whatever that is, 2, 0, I think. And there's some stuff outside the circle. But they want us to find this area inside. It's pretty crazy. This kind of line just comes into the circle. Slightly off the screen there, sorry. You knew what I was labelling. Oh, a lot of squaring. Chat says 196. Ah, instead of 198, thank you. That's not the first time I've failed to square 14. I failed to square 14 quite recently. Became a bit of a running joke, different setting, but I don't want it to be a running joke here that I can't square 14. But with a different group of people, I have a running joke that I can't square 14. So it's nice to have all these different communities. You can see all my mistakes with numbers and algebra. That's good. Suggestions in chat. Scalene triangle, yeah. And a sector. Anna says sector and triangle. Compare the sizes. Oh, what I could have been. I could have written 4/5 as 36 over 45. That would have been good. That would have been really good. Okay, 4/5 is 36 over 45, and then just use the fact that 45 is less than 49. That would have been excellent. Good comparison in chat. I like it a lot. So this seems pretty rubbish. People in chat have spotted the correct method. Triangle plus a sector. I guess we know where everything is. We know all the points are. This is no longer theta on the sector, but it's, you know, it's something. I said earlier, if I showed you a 3, 4, 5 triangle, you could say something about the, you know, the angles there. Tan alpha, you should determine that angle. That's something to do with that sector, and tan alpha is something to do with that 3, 4, 5 triangle. I keep mentioning the 3, 4, 5 triangle. I'm going to mark it in. It's not really good for the area, but it is good if you want to talk about this angle. The question also gives us a formula for the area of a scalene triangle with one corner at the origin, so that's good, which is what we have. We have 2 random points and the origin. We would like the area of that triangle, and the question comes with a formula, which evaluates to exactly 27 over 35. So it's all okay, but it's a mess. Anything you can actually do with a scalene triangle? Or are they just a dead end? We got to the end of the question. I didn't do the multiplication to work out 27 over 35. I'm sorry. But chat correctly identified which bit of triangle to apply that factor to and which bit is a sector of a circle. And then things work out from there. Scalene triangles, you still know some things. I mean, you know the cosine rule for scalene triangles, which I think we're going to talk about next week when we talk about trigonometry. But you know that looks really right angled, so let's not think about that. You know the cosine rule for the angles. You know the sine rule, I think. You know maybe some other stuff, like you could drop some perpendiculars and start trying to work out the area. You could do some stuff with scalene triangles. I wouldn't say dead end. I think dead end's a bit much. Keller knows Heron's formula, and Heron's formula is a lot of work. The hurrah might be for getting to the end of the long question, because we kind of got there. I skipped some bits. There was the weird bit I did out loud, which was probably impossible to follow. Sorry for that. Heron's formula, for people who don't know, this is no longer useful for maths, but there's this incredible formula where if you know the side lengths of a triangle, then the area is s minus a, s minus b, s minus c square rooted, where s is the semi-perimeter, or more practically it's a plus b plus c divided by 2. And I might have missed a factor of 4. Chat will tell me. I'm also going to quickly. I might have missed a factor of 4. No, I did not miss a factor of 4. Good. So, you know, that's nice. If you only know the side lengths of a triangle, you can find the area. Works for scalene triangles. This is on the theme of Sophie asking for facts about scalene triangles. But I don't think you're missing out. This is not brilliant, right? Because you're going to multiply 4 things together and take a square root. It's just a pain. The letter S has been added in here because otherwise it would be really nasty to write out all 4 of these brackets. It's just the only reason it's there. There's nothing inherently semi about the... never mind. Right. Is there a tan second cosec? Yeah, we should have more rules, right? We have the cosine rule for triangles. We have the sine rule for triangles. Is there a relationship between the cotangents of this triangle? Can you invent a rule? Maybe, maybe not. Maybe work one out from the other rules, I suppose, but I think that's not what you want me to say. I don't know. Why don't they teach that? What does that question say? Sorry. Why do they not teach that anymore? I don't know about anymore. I mean, I'm not sure it's ever been taught in A-level or equivalent. That might not be true everywhere. If there's someone watching from a country where you did learn Heron's formula in the classroom as a way to find the area of a triangle, like as a serious, here's something you could do to find the area of a triangle, then I guess let us know. So I think it is still being taught to some people somewhere. In some sense, I just taught it to you now. So hey, you can learn it on the internet. It's really not that. Okay, yeah, I don't. I'll give you an example, I guess. Here's the 3, 4, 5 triangle. Let's try and work out its area using Heron's formula. Heron says we have to add the numbers together to get 12 and divide by 2 to get s is 6. And then we have to work out this. We have to work out this product. Semi-perimeter is 6, so do 6 take away 3, 6 take away 4, 6 take away 5, and then take the square root of all of that. So it's 36, and you get the square root of 6. Just just not very good. Slightly off the screen. So you got to do quite a lot of work there. The better method is to remember that the 3, 4, 5 triangle is right angled. So you can use your right angle factor, multiply 3 and 4 and divide by 2. There's this kind of curse of knowledge, right? If you know too many formulas for the area of a triangle, then you might choose a bad one. Branching from sine plus cos both squared. Oh, sine squared plus cos squared is 1. You can get a lot of useful facts. Yep. What are the best A-level maths books? I don't know. I think it depends a little bit on your which exam board you're using, but I don't know. Not an A-level teacher. Hopefully you can get A-level advice from whoever your A-level teacher is, because again, I hope I'm not your A-level teacher. I hope this is not how you're learning actual A-levels. As the year 10 kid is, maybe. Right. What a global stream we've had. We've learned how they write circles in Scotland, sometimes, but not always how they write circles in Scotland. We've learned how they write vectors in Spain. And I think in the comments we're going to learn where they learn Heron's formula. Good. And other book recommendations. For the book recommendation, I'm going to recommend the book that I always recommend, which is Advanced Problems in Mathematics by Stephen Siklos, which I'm just going to put on screen quickly so that you can see it on screen. Here is Advanced Problems in Mathematics. Switch to the monitor view. Advanced Problems in Mathematics is a book about problem solving and preparing for university. It's by Stephen Siklos, who's no longer with us, but was a mathematician at Cambridge. It's free, you can just download it if you search for Advanced Problems in Mathematics. Although be careful, because if you search for it, you will probably also find someone who's trying to sell it to you. It's free, you can just have it. That's a good book. Right, good. I'm going to go. Thank you for joining in with the MAT live stream, everyone who's been here. Thank you for your help with. I'm trying to scroll back up. Thank you for your help with gestures, all of this, all the rest of your geometry questions. We'll be back in a week to talk about, I believe, trigonometry. If you'd like to get ahead and you'd like to see what we're going to be talking about, you can check the MAT Live page, link in the YouTube description, link on screen if you want to type it in somewhere. Hopefully, if you search for MAT Livestream, we come up top. We'll be back at 5 PM next Thursday for that episode of the Oxford MAT Livestream. Take care, bye. No, wrong button. That's just put me back. I've got a little, I've got a little desk-based thing with buttons on, which now means I can just press the wrong button. Instead of clicking the wrong button, I can press the wrong button. Let's try again. Bye.